You know. All right. Everybody's on page 41. Mario, are you okay? Kevin, you can move the desk if you want to. You were going to block him. Okay, thanks for being a good team player. They're going to take good care of you. Everybody else is good. All right, so, oh my gosh. Sorry about that. Yesterday, introduced you all to the fundamental theorem of calculus. Fundamental theorem of calculus, also known as the FTC. And for the sake of Flor, who wasn't here, for Jose, who wasn't here, for Henry, who wasn't here, that maybe haven't watched the video yet, I'm going to get hands on this. What is the fundamental theorem of calculus? Just Gonzalo, I taught one person yesterday, 2 people, 3, maybe 4, maybe 5. Daisy, what's the fundamental theorem of calculus?
I know the equation.
Yeah.
F of B.
F of B.
Equals F of A.
F of A.
Minus the.
What?
I mean plus.
Plus?
The definite integral.
The definite integral.
Of F prime of X.
Of F prime of X with respect to X.
From A to B.
Yeah, I gave it away there, didn't I?
No, I just didn't know how to say it from X equals.
Okay, for all the folks that were here, fundamental theorem of calculus, we're okay?
Yeah.
All right, what's the easy way to remember this? I want to get some hands on this. What's the way that you remember this so it is easy? Andy, what did we talk about yesterday?
Final.
Final.
Equals initial.
Final value is equal to the initial value. What's this last one though?
The rate. Oh wait.
This is a rate. F prime is a rate, but the whole integral represents
The accumulation.
it represents the accumulation. Another way you could say it, Jeanette?
The rate of change.
Well, F prime is the rate of change. Right, it's a how much. I want to keep coming back to this. This integral represents how much, what happened, Jeanette? How much what?
The function changed over that period.
The function changed from x equals a to x equals b. And right now, what I'm hoping is everybody's like, oh yeah, fundamental theorem of calculus. I played with this yesterday, and this was built on something that you already knew. What? Based on your 4th grade experiences. Right, we did the question example, and I think for the most part you guys were good, and that made this sticky. So I want to try that again. I want to see how good you are in the idea of average. Jeanette, hold on a second. So there are 2 problems here, built on a little bit of background with my baby brother Jeff, who's now like 35 years old, still, oddly enough, lives at home with my mom and dad. I would rather die. I would rather die. So your goal in the next 3 minutes, working in your groups, is to solve these 2 problems that involve finding averages. Everybody in the room passed 6th grade STAR and knows how to find an average. Right? We're about to find out. Okay, you've got your peers, get some help from them. My timer's going to go off. I'm interested in your number, but I'm far more interested in your process. I want to be a proud papa. If you need to use a calculator, feel free to use a calculator. I'll try not to embarrass you too much. On Monday, Jeff ate 23 M&Ms. On Tuesday, he ate 79. On Wednesday, 32. And on Thursday, 122. On average, how many M&Ms did he eat each day? I want a number, and I want units. Seeing a lot of people working with the right numbers, not seeing units. Really care about units and your explanation of the answer. Perfect response. That's looking good. Looking good. Keep going. Go to that middle school problem. Your son's looking good. All right, good. Keep going. Keep going. Nice. Looking good. Looking good. Okay. Just about everybody that I've seen has said, okay, we've got 23 plus 79 plus 32 plus 122, and we divide by 4 to get 64. 64 is the average. What I want to see as an explanation is, on average, start with on average, what happened? Jeff ate 64 M&Ms each day. Okay. Try that middle school problem. It's actually kind of an AQR question. Don't say approximately, like on average. On average. I definitely want to see on average. Okay. Not seeing as much success with the second one. For each of the first 4 hours of the day, Jeff ate 15 M&Ms per hour. For the next 5 hours, he ate 12 M&Ms per hour. During the next hour, he ate no M&Ms, probably because he's throwing up, because you shouldn't eat that many M&Ms. Finally, for the last 6 hours, he ate 8 M&Ms each hour. On average, how many M&Ms did he eat? I saw somebody who said this. They said, okay, I've got 15 M&Ms plus 12 M&Ms, plus he takes a break, plus 8 M&Ms, and we divide everything by 4. Okay, and some good responses, like folks are like, this is not right. Sylvia, what's wrong with this? Why doesn't this work?
Because you have to multiply each one by the amount of hours.
Why?
Because he didn't just, like, multiple hours passed. It wasn't just 1 hour for each one.
Right, what you're saying here is you ate 15 M&Ms for 1 hour, but that's not what happened. What did he do?
You ate 15 M&Ms for 4 hours.
15 M&Ms for 4 hours. So Jackie, how are you going to account for that?
4 times 15.
So I'm going to say it's 15 times 4. That counts the first 4 hours. Then what?
Plus
Plus what?
12 times
Plus 12 M&Ms
5
for the 5 hours. Plus,
1
0.
times 0.
okay, plus he actually gets some sense in his head, and he says, I'm not going to eat an M&M this hour, times 1, plus, what do we got here? 8 M&Ms times 6,
160.
and what do we divide by?
Once you do 160 and you divide it by the total hours.
So it's going to be 116 divided by the total number of hours?
168.
Okay, how many hours?
16.
16 hours. Total M&Ms divided by hours. Total M&Ms divided by hours. Everybody good?
Yeah.
All right, so we get 60, we get another 60, that's 120. So this looks like 168 divided by 16, so the right number is 10.5. How many guys honestly had 10.5? Okay, now I need the explanation. What's the explanation? What's the sentence? Henry, what's your sentence here?
On average, Jeff ate 10.5 M&Ms per hour.
On average, Jeff ate 10.5 M&Ms per hour. Now, if you really want to get sexy about this, I'd say for 16 hours. Does he ever actually eat 10.5 M&Ms?
No.
No, but on average, we'd say he eats 10.5 M&Ms per hour. And you get that by total number of M&Ms divided by the number of hours. Everybody okay? Okay, welcome to calculus now. I'm not going to tell you anything. We're going to check in about 2 minutes on this. Here's the calculus version of this problem. The graph at the right represents the rate at which Jeff was eating M&Ms, J of t, measured in hundreds of M&Ms per hour over the course of a 12-hour period of time. Using this information, determine the average rate Jeff consumed M&Ms during this 12-hour period of time. 2 minutes, this is much more of a push, but you can do this. I have faith in your smarticle particles. Nice. Nice. Trust the smarticle particles. Feel free to have a conversation with the folks around you about what your plan is. See, every group seems to have at least one person who's got a good idea. Share that good idea. What?
I was thinking the baby's very like the nice
Son, no.
So we need a second read.
What else do we have going on over here?
I was thinking that the initial ID could be minus quantum, because it's been 0 hours.
Okay, at 0 hours, he's eating 9,000?
I mean 900.
900 is how fast he's eating in that 0 hour. But my question is, how much? What's he eating?
980.
How did we find average in the first one? We looked at the total number of M&Ms that he ate. And then we divided by the number of hours. What about the second one? In the second one, we find the total number of M&Ms that he ate. Total number of M&Ms that he ate.
Saying to find out.
Yeah, it's average, okay, but it doesn't always like that.
All right, friends, I want to pull this together. The key is, and we've seen this in the first two problems, average was the total number of M&Ms, and then what? You find the total number of M&Ms, and then divide by number of hours. This guy over here is a rate function. This is the rate. It's a how fast. This is how fast Jeff ate M&Ms. What I want to know is, how many M&Ms does he eat? What are we going to do? How do you go from how fast to how much? J of t is how fast he ate M&Ms. What I need to know is, how many M&Ms does he eat? The way that you're going to get to how much, and some of you have it on your paper and I think you're still a little reluctant to talk about this, is you're going to do an integral. Because when you integrate a rate function, if this is how fast, then the integral is going to have to be how much. It's how many M&Ms you ate. What's the time period I'm interested in here?
0 to 12.
From 0 to 12, and then I'm going to have to divide by your total number of hours. How many hours? 12. So if that's what we're going to do, and I realized this was the thing I was hoping your smarticle particles would just tell you to do, and for some of you, you got there. Well, now I need to go find the area. This should be the thing that everybody in here knows exactly what to do. How are we going to find the definite integral? We're going to find the area. Now, sometimes I give you the function and you type it into the calculator, but I need to find the area from 0 all the way out here to 12. And depending on how you see this, maybe you do a rectangle, a trapezoid, And another trapezoid? Okay. So if I'm going to do the first one, the rectangle has a base of, what is that, 3? And what's the height?
900.
9. Oh, 9.
What's the height? Be careful on this one. Jackie, 900? Why 900?
Because it's hundreds of M&Ms per hour.
We're measuring in hundreds of M&Ms per hour. So when you say the height here, it's going to be 900. Plus, now I get to the trapezoid. Area of a trapezoid, 1/2 base 1 plus base 2 times height. So it's going to be 1/2. How long is this first base?
900.
Still 900. Plus the second base
200.
is going to be 200 times the height. The height is how far do we go? 4. Plus the last one, 1/2. Your base is 200. Your second base, what is that? I can't really see. Is that
1,400.
1,400? Times your height, how long is that? That's going to be, I think, 5. And then we divide everything by 12. For the folks that already did all the calculations, what do we get?
741.66.
Okay, Jackie's got an answer on this. Anybody else get to type it all into the calculator? Okay, Axel agrees. Everybody else get this into your calculator. You need the practice. 741? Okay.
Is it 14?
Yeah. 741.667 seems to be the number that keeps coming up. Okay, I need the explanation though. So on average, what happened? Jeff ate, on average, Jeff ate 741.667 M&Ms each hour. Each hour for 12 hours. Now, some folks had this for their answer. They had 7.416. Where's that coming from? Let me get some hands on this. Why are folks coming out with 7.416? Paul, what do you see? One more time? They didn't see the hundreds of M&Ms per hour on the units. Can they fix it?
Yes.
Destiny, how are you going to fix it?
Can't you just move the decimal?
All right, you could just move the decimal place. That's one way to fix it. How else could you fix this, Kevin? You can multiply by 100. How else could you fix it, Gerson?
Add the word 100.
You could just add the word hundreds. Because we're measuring on the y-axis in hundreds, you could just say, on average, Jeff ate 7.416 hundred M&Ms each hour. Are all the friends mostly okay? Okay, clearly this whole day is not going to be about M&Ms, although that would be wonderful. So let's look at the calculus, and then you guys are going to get some practice. So I want to generalize this a little bit, because I've never seen an AP Calculus exam question ask about M&Ms. I'm sure. Maybe I need to submit an M&M question and see what they do with it, and then it'll be on your exam, and you'll be like, oh, Mr. DeRozier wrote that one. Because, you know, he likes chocolate. No, I wish. All right, so here's what we're going to do. In general, if you have a continuous function, the average value of that function on the interval AB is going to be this. So I've got some function. Here's f of x. Here's x equals a. Here's x equals b. I want the average value. Well, what do we do with the M&Ms? You added them all up to find the total, and then you divide by how long the interval was. To find the average, We're going to integrate because the integral is an adding. We're adding up the area. And then we've got to divide. What are we going to divide by?
How long the interval is.
How long the interval is, right? That 12-hour interval for Jeff, I'm just going to divide by how long the interval is. How long is the interval?
B minus A.
B minus A. So your average value is the integral from a to b of f of x with respect to x divided by b minus a. Some textbooks are going to write it this way, 1 over b minus a, the integral from a to b of f of x dx. Same? Different? This is exactly the same. Rather than saying divide by b minus a, they're saying multiply by 1 over b minus a. And everybody's good? These are all the same? Ta-da! That's average value. That is about what I've got for you today in the world of average value. What I want to do is get you guys some practice time. So let's see what you can do with this first one. You've got 2 minutes. Whoever got the most sleep last night, you are in control of the cups. I'm going to check in 2 minutes.
That's just
Green, things are good. Yellow, you've got a question. Red, you're in crisis mode because nobody knows anything. Blue, when you're ready for me to check an answer.
no, you don't plug anything
For DFX?
for DFX. No. Because I think even you don't plug anything for DFX.
We're trying to find the average. This one is just
Seeing a lot of good setups. Uh-oh. Okay, just want to make sure we're all on the same page here. I want the average value on what interval?
Negative 3 to 6.
From -3 to 6 is where I want the average. So your setup, you have to find the integral from -3 to 6. And then divide by 6 minus -3, or 9. I saw a lot of folks when I was walking around that did an integral from 0 to 4. Where are my 0 to 4 folks? Sylvia, why are you thinking 0 to 4? I'm not trying to. I'm just trying to figure out because there's like so many people that have 0 to 4, and I don't know why we're going with 0 to 4.
It was just what I thought.
Okay, so you're not sure why, Daisy. Why did you go from 0 to 4?
Because it's asking for the portion of the graph from x equals 0 to x equals 4. That's what I thought. I don't know if that's other people.
Okay, so maybe that's where the 0 to 4 is coming from. That you're thinking that that's where I want,
Yeah.
but it says determine the average value for the function on that interval.
I thought that was the.
Is that just like extra information?
No, this last part, it's important information. The portion of the graph from x equals 0 to x equals 4 is a semicircle. I needed to tell you it was a semicircle so you can find the area.
Okay.
Okay? So, but thanks for helping me understand the 0 to 4. We're reading this part in the wrong way. Okay, curious, quick show of hands, honest hands. How many of y'all have this as your setup? Okay, so good news. First point earned. Okay, maybe you want to write it as 1 over 9, the integral from -3 to 6, f of x dx. Now what? What's your next move?
Find the area.
We're going to go find the area. Henry, who's Harry? Henry, how are you going to find the area from -3 to 6? What's your plan?
Split them up.
Split them up. Split what up?
Triangle from -3 to 0.
Okay, we've got a triangle from -3 to 0.
The semicircle from 0 to 4.
Semicircle from 0 to 4.
And a triangle from 4 to 6.
And your triangle from 4 to 6, but we need the area for all of these, right? All right, so who's got the area of the triangle from -3 to 0 for me? What'd you get? -9 for the triangle? Why negative?
Because it's only this side, so you go from right to left.
But hold on, if you're finding the area from -3 to 0, you're moving in the correct direction, so it is positive. There is going to be a negative area, but it's not this one.
It's gonna be the semicircle?
It's going to be the semicircles. So you've got 1/9. Area of your triangle is going to be a half. The base is, what is that, 3? And the height is 6. Kevin, you had said -9, right? But +9? So 1/9. Area for your semicircle is pi r squared divided by 2. So pi times 2 squared divided by 2. Have to make it negative. And Jeanette, what about that last triangle? You go what?
6.
6. So 1/2 times 2 times 6. Okay? If it's free response part of the test, done. Get out of there. If it's the multiple choice, you have to simplify. Not too bad to simplify. We've got 1/9 over here. 9 minus, what is this, 2 pi? Plus, I was told that was 6. So I'm just going to leave it 15 minus 2 pi over 9, or 1/9 of 15 minus 2 pi. If it's calculator active, feel free to pop it into the calculator. Destiny, then about.
This whole unit, anytime that any area, anything is under the x-axis, it have to make a negative.
Area below the x-axis always counts as negative. You know.
In what situations do we do the absolute value of the integral?
Total distance traveled, we do the absolute value. And if I actually use absolute value bars, I can use the absolute value. Oh.
If it said the integral from 6 to -3, would it be?
If for some crazy reason I wanted the average value from 6 to -3, then you do the integral from 6 to -3, that's going to introduce a negative, which would just be weird.
And the one under would still be negative?
And then it would still be negative. I'm not ever going to do that to you. Andy.
Is the 1/9 is from the second equation?
What?
The 1/9 is from that equation.
The 1/9 is because we were dividing by 9 because that's the length of the interval. We're okay? All right, good. Another 2 minutes, see what you can do. Next one is calculator active. Paul, if you can do the work on the calculator, but I'm not going to show and tell for 2 minutes. And I want to see, I want to make sure that you are showing me somewhere on your paper this setup. Because what I see is you've got all like the right numbers, but I'm not sure where they're coming from. It does. Thank you very much. That's going to make me happy again. Number 2.
This doesn't count.
Right, this is a calculator active question. Use it for all that it's worth.
For the function, you find the average value of the portion of the function is switched between you find the average, right? Yeah, like that basically. So I guess.
I want to remind you, all answers have to be accurate to 3 places or more all the time.
And then by 9, and then you just plug it in for f of x. So this will be 3x squared plus 6x plus 1. But the first quadrant. Is it 1, 2, 3, 4 or 1, 2, 3, 4? Or 1, 2, 3, 4?
Oh, I know.
Okay. right here. No, 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 actually, I'm glad where you are is good. Come on. Ah! Sabotage. It worked. Now I know what happened. Okay, so awkward. Why are you not working?
All it is
Because I had 0. Gotcha.
No,
not a problem.
No, pentagram. Sa demonyo.
Sorry. Come on, Harper! All right. So, Paul, can you show me the graph? So I think for the most part, everybody was like poised and ready to spring into action on this one. I saw just about everybody graph it on the calculator. Right? I said find the average value, and you know a formula. You're like, oh, it's the integral from a to b of f of x dx divided by b minus a. I want to get some hands on this now. What made this problem harder? Where am I messing with your heads? Where's the push coming from? Some of you are like, from the time you say hello, that's where the push comes from. Henry, where's the push coming from here?
when you say the first quadrant,
Yep.
and well,
So first quadrant, that's this guy over here. What haven't I given you?
zeros.
I didn't give you an interval. You have to figure out what the interval is. You know the function. What's the interval? Well, it's going to be whenever the graph is in the first quadrant. So where do I start being in the first quadrant? At 0. So that gives me my lower limit is going to be 0. When do I stop being in the first quadrant? Right? Some of you had like the 2.1547. What's the significance of the 2.1547? It's the, fancy word? It's the root. It's the root. Yeah, there we go. So you're going to find the root. And Paul already found the root and said like 2.1547. I want to grow your calculator skills a little bit here. You need that 2.1547 in your calculations. We're going to store it. To store, Paul, you need to go over to the 2.1547 and click. Click so it highlights. And then on your calculator, go over to var, store var, and give it a name. What would be a good name to give it here? B. Stay away from X because X already gets used a lot on your calculator. So call it B. And you're going to know that you did this correctly if this guy shows up in bold. How many guys have it in bold? You stored correctly. Destiny was able to do this correctly. I want to make sure everybody's got this skill. So one more time, it was click so that it highlights var, store var. And then give it a name. Okay. Now let's go over to the calculate. What we need to type in, you're going to do an integral. From where to where? From 0. Now you could say 2.1547, or you could be smart about this. You just did all this work. What's the upper limit? B. You're integrating f of x, which you probably stored in your calculator as f1. Don't blow it. Don't blow it. You want the average. So then you get a divide by b minus 0, which is just b. Paul's doing it in 2 steps. He found the area, and now he's dividing by b. Could your calculator do this in 1 step?
Yeah.
Of course, I would just put parentheses over here. And if all goes well, what are we getting? 2.821. 2.82137. All you need is 3 places after the decimal. How many guys are honestly getting 2.821? Okay. All right, see what you can do at next. 2 minutes. You get to use your calculator first, but then you have to explain to me how you would do this without your calculator. So you've already done that. That's good. Go over to the calculator.
Go to,
And then you're going to type in
0.
this integral expression. You're
You're
going to integrate
press that.
0 to b. Your function. So, but you're going to have to type it in as f1 and divide it by b.
Now you press bar.
You grab.
You press it. You got it. And then you press this one. Then you just give it a name. You go to calculator.
Would you get the 6.7?
Whoa.
That's the integral. Just put in.
You just like type this up.
Nice. Keep going. Keep going.
The integral from this one?
Once you got it, show
From the
me.
first one? Second one.
It's like the same thing.
Keep going, Kevin.
Sine, cosine, negative sine.
Okay, so you're right now. It's there. Okay, what did we get? What did you get for your average? Dude, keep going, really. Yeah. All right, walking around most folks, bless you. Bless you, Chris.
Thank you.
Okay. Most folks, now this one maybe at first you're like, hey, that's not too bad. I want you to find the average value. I gave you the function. I need to get a new marker there. I gave you the function. I gave you limits of integration. Maybe they're a little tricky to plug in, negative pi over 4 and pi over 4. And then you divide by pi over 4 minus negative pi over 4. I'm curious how many of you guys had that as your setup like right away. Because this is how we find average in a calculus class. You find total area, you divide by the length of the interval. You type it into the calculator and you get 0. Paul, can you give me the graph of sine of x? Now, some of you were not at all surprised that the answer was 0. Where are the folks that were not surprised? Okay, we got a lot of folks that were not surprised. You go, why were you not surprised that the average value was 0? What did you know?
That the waves cancel each other out since they're the same area on top and at the bottom.
Okay, so we've got the graph of the sine function,
Oh, I know.
which you guys know and know very well, thanks to Mr. Link and your pre-calculus folks. There's something special about the sine function. There's a word I'm looking for here. It begins with an O.
Oscillation.
Oscillation is an example of a word that begins with an O. Thank you for that. And the graph does oscillate, but there's a reason why we're getting 0, and it has to do with the word. Not opposites, yet another good O word. It's like Sesame Street for teenagers. I love it. Daisy?
Since sine of x is an odd function.
Oh, thank you. It's an odd function. You're like, how was I supposed to know that? It is. You've got an odd function that did sound like a fart back there. Just want to let you know. You've got an odd function over symmetric limits. You're going from negative pi over 4 to pi over 4. Those limits are balanced. what Adele is saying is you've got this area down here which is negative. You've got that area up there that's positive, and what has to happen? They cancel out because they are equal but opposite. I understand the opposite. Oscillation, Rebecca, is about the ends. I think we're all good? All right, keep going. So you can do number 4. All those words I just used? I'd say because the sine function is an odd function over symmetric limits. The area is
Yeah.
so the
If it was an odd function, you know that the areas cancel out when you add them up.
How are we doing with we can do this. Mandy, did you have a question?
Oh yeah, but it's not about this.
What is it about that?
It's not about this.
Okay. I know. It's about how do I look so good all the time? Easy.
I left my calculator charging.
Okay. And if you trust me with your calculator, I can try taking it home tonight. Alright, so tonight's homework, assignment 81. You've got the problem. Solutions are coming your way. Do not be stupid about this. Do the problems first, then check your work. See you tomorrow.